Hi, this is Ming Yao from Singularity Engineering, and in this video I'll look at how to keep a box sealed, and we're going to look at fasteners model using bolt pretension methods. So first we're going to add in a material. We'll use polyethylene, so we have a plastic box, and in this box we want to make sure that it's sealed, and we want to fasten it with a couple of bolts. Obviously how well the box is sealed depends on the amount of bolt pretension you have, and I'll show you some quick ways to set up bolt pretension and this type of nonlinear contact analysis using ANSYS Workbench Mechanical. So it's a simple geometry. It's not a well-designed box. As you can see, it's just flat. The lid just lays flat on the box itself. I left a couple of holes for bolt pretension, where the bolts will go through to pull the lid and affix it to the base. So both parts will be made of polyethylene, and we'll assume the bolt is made of steel. So ANSYS automatically detects a contact between the two. We're going to make this a nonlinear contact, and I'm going to make it a frictional contact with a frictional coefficient of 0.2. The next step is we want to define some bolts. So let's go ahead and select where the bolt holes are, and we'll put beams in there. So these are, I think they're 1.5 millimeter bolts. ANSYS models these bolts as beam elements, and we can extract a variety of information from these bolts. 1.5 millimeters. And now we can go ahead and set up the simulation. So the bottom will be fixed, a fixed support. On top here, we'll make this a multi-step analysis. So I'll have two steps. With bolts, you can sequentially tighten them and then apply other loads. So if I want to, for example, tighten both of these bolts one at a time and then add pressure in on the inside, it'll be a three-step simulation. In this case, I'm going to do a two-step simulation because the only load in my analysis will be from the bolts. It'll be nonlinear because we have a frictional contact between the lid and the housing, and I think that's all we need. The load will come from my bolt pretension, so I can pick my beam connections. This first beam here, this will be loaded. I'm going to shorten it, adjust it by 1 millimeter, so it'll shorten the bolt by a millimeter, and then we will lock it in place. My second bolt will be this one here, and this will initially be open, so we load the first bolt in, then we will adjust the length of the bolt again by a millimeter. Because this is a nonlinear analysis, we do need to typically assign some, let me double check to make sure this looks right. Yeah. Let's assign some uh, time stepping controls. So we want to start with around 10 steps and then go maybe to 1,000 steps. So that's all we need to do for this analysis. We can go ahead and run the simulation. It's a pretty coarse mesh, but we can certainly refine that to get a better result. I left this course to run so that we can run the simulation quickly. And the simulation has completed. So let's take a look at how my box is deformed once the bolt pretension is applied. So you can see that first, one side of the bolt is engaged, then the second side of the bolt is engaged. If you zoom in, you can see the edges of the lid lifting up a little bit due to the force of the bolt pretension. We can adjust the bolt pretension to ensure it doesn't lift up dramatically. Take a look at the stress. So the maximum stress is occurring around the bolt holes as expected. And we can look at the contact tools. So the contact tools here under status tells us how the different surfaces are touching, how the contacts are working. Sticking is where there's friction. So there, at the end of the simulation, there's a couple of areas where the lid is in contact. Anything yellow means that there's a small gap between them. So obviously this lid is not going to be be sealed. There'll be a lot of leakage, a lot of area for the moisture to get in. And here on the orange area is sliding, which means that it's just touching, but there's no frictional force between them. We can also look at the gap. So let's see if there are gaps between it. So, you can see the gap, maximum gap we have in the corner here is 0.4 millimeters. As we get closer to 0 here, there's a small amount of gap, and then we have actual contact in these areas, in the red regions. So it shows that this is not a very good seal, not a properly designed lid. We can also look at things like frictional stress, sliding distance. We can even add fluid pressure. So fluid pressure is a contact setting that allows us to assign pressure around the contact and have that pressure spill inwards and try to open up the contacts. So this is a quick demonstration of nonlinear contact analysis with bulk pretension. And the application is we're trying to seal a box, and we want to look at in which areas is the box sealed and in which areas it's open, so that leakage can occur. Thank you for watching this short video. If you enjoy it, please like our video and visit us at singularityeng.com. Thanks and have a good day.